Well, good afternoon again, everyone, and welcome to our chapter 6, design. Last week we did the implementation chapter, which ideally should be done after design. However, to this week we'll be doing the design chapter. Before we get started in terms of the design chapter, just wanted to have a small discussion as well with you in terms of now that you've been implementing your application, how do you see the role of design, right? Now, before we get into it, I want you to just draw a reference. So for example, you're going to build your house. It's a pretty big house that you're going to build, and you have no architectural plans or anything like that. You have an idea of the house that you want, right? But the fact is that the builder that you hired is going to build the house here for you, and there are no plans, right? What are some of the potential challenges you might find happening in such a situation? We're just talking because what I'm trying to do is help each of us understand the role, the importance of design in terms of the application. So imagine that you're building your house, you have no architectural plans, and you hired a builder to build the house. Tell me some of the things that could possibly go wrong.
You get things in places I don't want, you don't want it. Or you can make decisions that we had to change if it didn't really plan the design stage at the project, basically, or the house.
Without the plan, would the builder know exactly what it is you want in terms of like the width and the size of the rooms and all of those things? Is it the layout, where the walls should go and those sort of thing?
Yeah, that is what I'm trying to get at.
Right, gotcha. What if a mistake is done? Like, so for example, he built a room based on how you perceive it and then realize it, the window, I put the window in the wrong place, etc. Camille, if that was your house, what would some of the challenges be for you if he had done that, right? And you really wanted it the other way around, what would happen? What you think will potentially happen for you?
You'll be spending more money basically because you had to repair.
Correct.
Exactly where you already spent to do and do.
Yes, and money and time, totally, very much so. All right. So we recognize that, look, without a design, it's like kind of operating blind in terms of building, because you're building without really knowing exactly how it would look, right? And those are some of the challenges. And the problem is, if you try to undo it, the cost in terms of time and money and all of that is really expensive. Let's take that now and apply it to your project, right? You have to code the application. And which of all the phases in the project, which phase or which one takes the most amount of time for you guys? Which phase of the project you think is the most difficult for you? Is it the coding, the application, the implementation phase? Is it the design phase, coming up with the requirements? Which phase you think has been the most challenging for you guys? Anyone?
Implementation phase for me.
Implementation phase, and that's because of the coding. How much time you think you all spend on coding though, in terms of on average for the week?
Every day.
Oh.
3 hours.
4 to 6 hours.
Wow, that for many of you, it's probably exciting as well, especially when you're getting things done. But sometimes you spend a lot of hours and you get very little done. Like you haven't finished a function, but you probably spend about 8 hours, and yet meaning like a feature hasn't been completed at all, right? So you realize how important it is. Therefore, recognizing now that how much time it takes to complete the application the way you really want it to be, that you don't really have time to go back and change and undo, right? Have you tried building a feature that you don't know exactly what it would look like in terms of what the screen would look like, etc.? Have you been in any of the class with Marcus where you all are building a feature, but you have no idea what it will actually look like, where all the fields will be, etc.?
Yeah.
Now, the reality is when you're working from there where you don't know exactly what things are going to be on the form, where they should be located, etc., you find that you spend a lot of time deliberating as you go through the building of the application, because you're not sure how all the things piece together very well. And because of those reasons, right, a design, the design becomes crucial in order to help you to do a good implementation. So the design chapter is really critical because what it does, it basically lets you see what the application looks like before you actually start coding it, right? And it's very much the same thing that the plan for the house does. The plan for the house, and I'm not talking about the older versions of plans now only. Yeah? If you've looked at Property Brothers and stuff, you'll see that these new plans now are all three-dimensional, and you can actually see the color, your cupboards, and all of those things, the layout of your house. You can actually do a walkthrough of your virtual house, right? Because it's all design, right? And very much with the same thing with your application. If you could picture it and you actually see where all the pieces are, where they laid out, etc., the order at which they should go and that sort of thing, it makes the building of the application an entirely easier job than before. So all of these things are just reasons why the design chapter is so crucial in building your application. It reduces the amount of time it takes to build the application if you've done a very good design. So design, therefore, is very important for us. Good. So with that in mind, let's get started now. Our word today is your life is your message to the world. Make it inspiring. So many times we prefer to go through life where we just, we're not concerned about interaction, being a role model or anything like that, just live on our own life. And that's fine for many of us. But the truth is that I believe we are created from something much greater. And I believe every one of us have the ability to inspire, to change, and to bring about change to the world. We don't just want to be inspired by others, but the truth is we should also be inspiring others to be their best. So, and a lot of that could come from our words. We don't have to be anything great or grand, but we could choose to use words that could build and lift up people as well. We could choose our life to be an example as well, simply through honesty and integrity in our lives as well. So we are being encouragement to many others as well. So continue to inspire others with every decision that you make daily. And it's fine if you falter at times. We're not perfect, but even in life, even when you falter and you get back up again, you are encouraging someone and inspiring them as well by not giving up. So we continue our reporting structure, and this is the layouts of the chapters, right? So today we're completing chapter 6, which is design, but just a note, last week we did implementation. So at the end of today's class, we would have finished 7 of the 10 chapters. So we just have 3 more to do after. That means we have 3 more weeks of classes, right, for the write-up stage. So in terms of the design, what's the purpose of this chapter anyway, right? So really the purpose of this chapter is to discuss the design decisions that you would have considered and the reason you chose one approach over the other. And of course, it would include consideration for the human side of it, as the HCI issue, human-computer interaction issues, and how these issues would have influenced your design. Now, in terms of the structure of your chapter, every chapter will have an introduction, and we will discuss this again. The introduction simply is to tell the reader what you're going to cover in the chapter. And if you look at the overview of the chapter, you will basically see already what we're going to cover. So in the design, we will look at design of the back end, which is the database, as well as the design of the front end, which is the application. So even for the database, you don't just go and start creating a table. You need to know what fields are in the table, etc. And that's the role of the design chapter. The design chapter from the database side will help you to come up with a set of normalized relations, right? And these will be the tables that you would eventually have in your application. But of course, it's not just about the product of just coming up with the tables. It's the process that you go through. The university is very concerned to ensure that you follow proper approved approaches as well to design, rather than just a random ad hoc approach to design. And this approach here, for moving from an ER diagram to normalization, logical schema, data dictionary, is the generally recommended practice you'll find in a lot of textbooks as well. Then we'll go to the application design. And in designing the application, you don't just start by sketching screens. Nope. The first thing you need to do is understand the principles of good design. Because you see, if you just go and start designing and you don't understand elements of a good design, then you will eventually have a lot of traps within your design. It's much the same way, for example, like if you're going to build your resume and you never read about what should be in the resume, etc., and you know how people use it, etc., then you may be designing a resume simply to suit the fact that you have information about yourself. But what you're not recognizing is that how employers use your resume, etc., right? And how your resume is used as a marketing tool to get that job as well. So it's important that you understand the approach to proper design before you start designing. And that's when Nielsen heuristic comes in. What Nielsen does, he's the godfather of design. Basically, he will tell you, look, when you're designing an application, have a consistency in your application. Why do you need to have consistent screens in your application? Because you see, users who are familiar, once you're familiar with one screen and you go to another screen, it reduces your learning curve. A human element is if you're a new task to do and you are not familiar with it, you will probably dilly-dally in your mind and try to duck doing it because you're not fully aware and you don't feel confident about it. But if it's a task you've done before and I tell you go and do it, you would because you know what is required, you would likely do it faster, and you will probably be more amenable to starting it right away rather than postponing it. And that's what Nielsen heuristic is about. He's basically trying to equip you with all the rules that you need to follow before you start designing. So simple rules could be, for example, have consistent layout. So if you look at Microsoft, all their applications, Word, Excel, Access, they use the same set of icons, etc. So as you move from one to the other, there's already a familiarity, right? So he made one recommendation is for consistency in design. Another one would be to keep users informed, right, as you go through. So that keeping users informed will be through useful messages and prompts and stuff like that, right? So we will go through a lot of these in terms of the design from Nielsen heuristic, and then after we understand what Nielsen is saying, we're going to apply that now by doing sketches of what the screen should look like. We will do wireframes and an interactive prototype, and these are continuous levels of refinement of your design until you get to the highest level before you actually start coding. So this is the overall structure of our design chapter. Good. All right, so let's get into our first one, which is 6.1, which is the introduction to the chapter. As I've indicated before in all each introductions, the introduction should be a statement indicating the importance of good design in developing software artifact, right? So really what you're trying to say is, why is design such an important phase in the project? And you could research that, do a Google search. Why is the design phase important or crucial in building an application? And you should get some suitable answers that you can, of course, paraphrase. Additionally, you should include the aim of the chapter. What is the purpose of this chapter and what will be covered in this chapter? So to answer those 3 points, this is just an example of how you could answer that, right? So a poorly designed website can affect an organization in many negative ways, while a professional site will encourage visitors and inspire confidence in their customer base. Avoiding the damage that can be inflicted on your organization by poor website design is necessary to compete successfully in today's competitive environment, right? So those couple sentences we read there they basically form statements that talk about the importance of good design. Then you're getting to the aim of this chapter. This chapter includes a discussion of the design decisions that were considered in the development of the software artifact. And what will be covered in this chapter? It looks at the design of the database required to store the data, as well as the design of the user interface. It also includes consideration of HCI issues and how they influence the design. By the way, the HCI issues are the Nielsen issues we talked about a short while, right? And that's just an example of introduction. Introduction, 1 paragraph, just a few lines only, and ideally they cover those 3 points. Next, let's get into the database design. Now, why is the database design important, right? Well, the reality is that all of your data needs to be stored in a table. And your table need to have some kind of logical structure, because if your table is not well structured, it could lead to a series of anomalies. Those anomalies are like, you may have errors inserting, updating, deleting data, etc. So it's important that you practice good design. And practicing good design, therefore, will typically involve the following. Now, there are 2 different approaches to coming up with your table. There's the top-down approach, there's the bottom-up approach. The bottom-up approach is like, if you have like forms and stuff like that you would be using to collect data, you use the forms to come up with the table. That's a bottom-up approach. A top-down approach is where for example, you have an idea of the nature of the project and you start working on like what are the different entities are. So you start with what you call like an ER diagram, and then you model your scenario using an ER diagram, and you refine that ER diagram to ensure that there are no many-to-manys, etc. Which that process is called normalizing a ER diagram, which is converting it from a conceptual model to a logical model. After you've normalized it, then you come up with your list of tables, and that's the top-down approach, which is what we will be using in this session, right? And at the end of it, through those refinements, you will come up with a list of tables, right, in your data dictionary. And that's basically the end of the design phase, where as far as the database is concerned, right? So just a note, the product of the design phase, the end product, is a list of normalized relations. That's the purpose of the design phase. So it's a process you have to go through to get there. Let's look at the process. So even in the design phase, you'll just do an overview of the process that you'll be doing to create the design. So my recommendation is you should include a brief introduction on database design and why proper database design is important. Now, early on, we talk about design in general, but here we're being specific now because this section is the database design. We need to understand why proper database design is important. As mentioned before, the intent is to prevent duplication, to ensure that a fact is only stored once so that you can avoid insert, update, and delete anomalies in your table, right? Next, you briefly discuss the role of database design. What is the end product of the design phase and what is involved? As I mentioned to you, the end product here is a list of tables that are normalized, right? And then discuss any design decisions that need to be made in the approach to database design, such as the top-down or bottom-up. Now, I briefly indicated to you, now either approach is fine. However, because this is not an existing product or project, right, or a company that already exists that have paper that you're now converting from a paper-based to a manual to an automated system. You are simply conceiving this in your mind, and that's why the top-down is preferred. If you actually moving a manual system to computerized, they already have forms and reports, then you use the bottom-up approach, if that's the case. In this case, there is no real existing company and you are basically creating something, so the top-down approach is the preferred approach here, right? So this is just an example now of these 3 points that I discussed here to explain better what it is I'm saying using an example to illustrate. The first step in designing the software prototype was the design of the database. This step is crucial, as having a properly designed database that was normalized to at least a normal form would avoid any data redundancies, which would eliminate the insert, update, and delete anomalies. Of course, your site and author, I have Connolly and Begg. They wrote a database textbook, or several database textbooks for that matter. Although Connolly and Begg discusses both the top-down and the bottom-up approach to database design, this project focuses on the top-down approach, given the system is purely a concept that is being brought to life. Ramakrishna and Gurke, they are also writers of database textbooks as well. They recommend the use of bottom-up approach for existing databases where forms, reports, and sample screens for the existing system are available. So what we're saying here is we are just simply saying when the bottom-up approach is used, right? But we've already agreed that we'll be using the top-down approach. And the first stage of the top-down approach is the entity relationship modeling, which is discussed next. So I'm using the top-down approach, and the top-down approach starts with the ER diagram. And basically now my introduction leads me now to my next section, which is ER modeling. So notice even in your writing, you're linking your sections by one flowing into the other. In terms of ER diagram, I believe you would have had to do an ER diagram for the IPR, right? And we would have had some discussions of it in the classroom as well when we had that class where we came up with an initial ER diagram, right? But it was a smaller scale then, right? In this write-up now, you will talk about the role of ER modeling, right? So just to briefly, what we're going to cover here. So in this section here, you'll discuss the role of ER modeling, which is to produce an ER diagram, which will eventually lead to a logical schema, which is a set of tables and attributes, right, that you would use to store your data. Now, in order to come up with your ER diagram, how did you go about starting the ER diagram? So you have to discuss the process. So the process of producing an ER diagram would first involve studying your list of requirements that you would have had. Because remember, the requirements tell you what you need to do, what this project or application will be doing. And what this does, by reviewing your requirements, it will tell you what are the entities that you need to have. And what is an entity? An entity is simply anything that you could store data about. So for example, in your scenario, you're building a learning management system, right? Let's talk about the things that you could store information about. And I wanted to convert this now to just a discussion, right? So if I were to do, and I'll use an example first, if I was using an e-commerce system, I will need to store information about my customers. What do I mean by that? I mean, for my customers, I need to store like their name, their address, phone number, and email address, or things like that, right? I need to store information on my products. So for the product, it'll have a product name, a product ID, a description, a price, you know, things like that. So what we're suggesting here is I'm trying to show you what the entities are, and an entity is anything you can store information about, but I also gave examples of the information you'd store about it. Let's talk about your case study now and your project, which is a learning management system. And I'm moving away from this now and we're going more to our discussion now. And I'd like you guys to share a bit about some of the entities that you would be using in your ER diagram. And if we could have it more of a discussion and talk about like what are some of the what information you will store regarding your entities. So I'm throwing it out to you guys. If you could share with me any entity you recognize that you'll be using in your ER diagram. All of you have the right to speak. So come on, guys. Chris, you were saying? Crystal? Anything that in your learning management system, if you're not doing a learning management, it's not a problem. You could identify the system you're doing and an entity in your system, right?
The users table.
Right. Tell me some information you store about your users.
Well, their email address, their first name, last name. You'll store a password for them.
Very good. So those are, so basically the users therefore is an entity, and we've showed information about the user, right? And the thing is, now remember these entities are linked to your functional requirements, right? And one of the functional requirements is the ability to register and to log in, right? And in order to register, you need to get the person's username and password. And therefore, if you're going to do that, you need to store it somewhere, and that goes in the users table, right? So I'm showing you how you can link from your functional requirements to your entities. Can someone just call out a functional requirement they have in their system, and we can see how we could implement it? In a learning management system, you will have courses. Is that your course administration or course management part of it? Come on, guys. What it takes to get you all to talk a little bit more?
Creating courses.
Right. So courses, right? So creating courses, right? Now, when you're creating courses, would you consider course to be an entity? Do you have to store information about a course? Anyone can answer, not just the person.
Yeah. Course topic, the description.
Right. So the course has a name, it has a description, right? It may have a certain amount of credits, right?
ID.
And a course ID as well. So we have the course now. So that's the course itself, right? So let's stay on courses as well and the whole course administration. So under course administration or course authoring, the course authoring is where the lecturer creates the course and add content. Is that a feature for most of you?
Yes.
Right. So the creating of the course is one thing. Now, in terms of the content, right? in terms of the content for the course, a course will have one name, one, so a name, one description, etc., right? But let's look at the content. How did you guys break up the content of your course? And it could be done differently for different students. Did you have just one flat content, or did you have like it's broken down into chapters and chapters broken down into units, etc.? How did you guys do it?
Broken down from courses to topics.
Courses to topics. So a course is made up of many topics.
Topics.
Yeah. Well, I think it's topic would be the chapter in that case, I guess.
Or chapter. So a course is made up of chapter, and a chapter is made up of?
Of quizzes.
Well, we'll get to the quiz after, but like, okay, so
details just now from the units.
right. So a course is made up of topics or chapters, and a chapter is made up of units.
Yeah.
No problem. How did anyone else did theirs?
Yeah, good.
Guys, anyone else?
We kind of run similar in terms of the courses and the topics in terms of that. In terms of breaking it down. But is it that it just to provide the parameters, because we're not really concerned about how the content or anything? It just to provide the means of them to do it, right?
No, but you have to be able to provide, right? In order to do so, then you need to have somewhere to store the information.
Right. Yeah.
Right.
So, yeah.
That's where the table comes in, because remember, the table is to store information.
Right. Yeah.
So let's take a look at that process now. So let's say, for example, you had a course, and the course now is made up of chapters, and a chapter now is made up of units, right?
Right.
It means that you need to have a table for chapters, and you need to have a table for
Table
units.
for the units, correct.
And the relation now will be from a course. One course has many chapters, but that chapter belongs to a particular course. And a chapter now has many units. So you have 3 different tables, because in the units, you'll have details of the unit, like the unit
I understand. Yeah, I understand.
content and stuff like that, etc.
Yeah.
Right? And the same thing with the chapters as well, right?
Yeah, correct. Yeah, we have that in terms of because the matter assigned to a course, a topic to a different particular course, and no kind of stuff. We have to have multiple tables to assign.
Wonderful. So we looked at, now let's look at some other areas now, like quiz or assessment. Any one of you using assessments in your system?
Yes.
Guys?
Yeah.
Right? If you're using assessments, then assessment becomes a table, but the assessment is more than just one table, right? Because what happens is that, I'm not sure how you guys are implementing it. Is it that you're doing it where, well, remember, this doesn't always have to be how you implement it, but how you would like it to be, because really what we're doing is how you would like it to be, right? So in terms of how you like your system to work, is it that when you do a course, you create your own quiz, or ideally there's a bank of questions that you could use and reuse from, etc., right? And you could add new questions to it, and etc. Or is it that every quiz you just create your own separate quiz only for that purpose? How you all see it working, or how would you like it to work?
The second one, you just said, a quiz.
It's specific for the thing, or is it that you could have like a pool of question, and when you're ready to do a quiz, you just simply pull questions from the pool and assign and create a quiz?
I was looking at that option. I'm still unsure about that option. If I get it to work, then I might use it. But
No.
it's more like we would have quizzes, but the quizzes would like each quiz would have a certain number of questions in it. So I guess they would have a quiz ID, and that quiz ID have several questions in it. So we could have multiple quizzes with different sets of questions.
No problem. Now,
Yeah.
that will happen whether you have it as a pre-built or otherwise, right? So let's say, for example,
Yeah.
CXC is going to write, if a CXC exam, students are going to do multiple choice paper, right? Is that every question in that multiple choice paper, is it unique or a lot of them are repeat questions?
A lot of repeat.
Wonderful. And that's because what they do, there's a bank of questions, right? Maybe 1,000 questions, but every time you set an exam, you are pulling questions from that bank and creating a new exam. So using the same base of questions, of course, you could keep adding more and more questions to that list or database of questions, right? But every time you're creating a quiz, you're simply pulling questions from that database, as opposed to, you know, like you create a quiz, you do with questions, and this is a one-off use. So every time you create a quiz, you're simply making up new questions, you're not reusing old ones, etc. Right? So in most cases, you'll find that quizzes tend to be reused because there's only so much ways you could ask question on the same topic, right? So based on that, maybe the preferred approach is to have a table with a series of questions and answers. So one table will have all the questions with the answers. So you'll have the question, it'll have the answer 1, answer 2, answer 3, answer 4, like if it's a multiple choice, and it will have the correct answer, right? That's your question and answer table. That's the pool that you're using. But to create a quiz now, your quiz now basically has 2 elements to it. The quiz will have like a date of the quiz, the weighing of the quiz, the etc., and a name for the quiz. And then the quiz will have a series of questions. So the quiz has 2 tables. So it has the quiz itself, which has each quiz will have a single name or ID, a date for it, and that sort of thing, right? And a description. But a quiz will have many questions. And therefore you have another table to store the questions specific to that quiz. So this is how you go about with your ER modeling. So the whole idea for ER modeling is really using your requirements, right? The functional requirements. You will use the functional requirements to produce your list. So using your functional requirements to produce your list of entities, right? So that's what this is saying. You're studying the requirements to produce a list of entities. Entities would be like customers, etc. So we discussed the entities. The next thing is, now that you've come up with your entities, you need to put them in a diagram. And entities are related to each other using relationships. So to complete your ER model now, you need to identify the relationship between the entities. These relationships might be one-to-many, many-to-many, one-to-one, as the case may be, right? The most popular ones are one-to-many and many-to-many. To determine the cardinality of the relationship, meaning whether it's one-to-one or many-to-many, right? You have to look at the relationship on both sides, right? And then once you have all the relationships now, you then draw your diagram. So that's basically the process you went about producing an ER diagram. An example of writing this would be, the first step of the design process involves identifying the entities, which are items of interest, and the relationship between the entities. The requirements analysis provided most of the information for this phase of the development process as functional requirements from the basis of the data that you require. From the requirements analysis, the following are some of the entities identified. So now you actually specify. Now notice when you're writing it specific to your project. So while you're discussing the approach, you must also apply it to your project. So we discussed the approach, but now we apply it and we identify now the actual entities, such as user, customer, product, shopping basket, order, review, etc. So this is how you apply it, right? But as we haven't finished this yet, so those are identifying the entities. Now we identify the relationship between the entities. So after identifying the entities, the next step was to identify the relationship between them. This includes, and they give examples of relationship between entities. So for example, a brand has many products and a product belongs to one brand. A category has many products, but a product belongs to only one category. So what you're doing is that the first line is the relationship between brand and products, and you have to describe it in both directions, from the brand to the product and from the product to the brand, right? So look at the third one. This is a relationship between which 2 entities? This third one here. What are the entities here? It's between 2 entities. Can you identify the 2 entities? That's right, it's product and reviews. So the relationship here is between product and reviews. What is that relationship? A product could have many reviews, but a review is for one product. So what this is telling you is that the relation between product and review is a one-to-many. How did we get that? Well, this here, from product to review, it's many. So the many goes near to the review side. Now you have to flip it now, and you're starting from review going to product. A review is for one product, so the one goes near the product side. So that's how you tell this is a many-to-one relation. Let's look at customer and review. A customer can make many reviews. So you have an entity, customer, and entity review. And when you join them, the relationship, right? The relationship is called makes, right? Customer makes reviews. The many goes next to review, right? And from the review side, a review is made by one customer. So one goes next to the customer side. And you do this for your entities basically. And by doing so, you can already see the relationships that are building. And then the next step now is to produce your ER diagram. And this is an example of ER diagram. So if you want, wherever you see a line, that line is a relationship. Now, what this really ER diagram is lacking, it doesn't tell you which ones are one and which ones are many. It doesn't include the relationships in it, right? This is a better approach. You're seeing one and many, etc. This is a preferred approach to it, right, for e-commerce. However, this one I got from Marcus from Access, right? It generates the diagram, but it doesn't put the one and the many. So this is, oh no, so I think this was Access. This is one he had done on a diagram tool, but the ones and manys were not included. So it's lacking that. So those things.
Is it that we could, just by observing, we could see that the one that has multiple, like so like say from the like users, so there will be like a one to many because it goes into many avatars, backgrounds, and badges.
No, that's not how. Sorry,
How
it's done. You have to take a specific line and deal with this separately, right?
Oh, okay.
The many is nothing to do with the users have many arrows coming from it. That's not how many works. The many is unique to this here. Okay, let's take a look at this one here. Right, let's look at users and review. Let's take this relation between user and review. Ignore everything else and focus only between a user and a review. Right? Now, a user could make a user makes the review, correct?
Yes.
Could a user make many review, or a user is only allowed to make one review?
You can have many reviews.
Right. So one user here could make many reviews. So the many goes right here.
Okay.
Many goes here. Now let's look at the review side, and from a user, that review, so you're taking one review from here. That review, that specific review was made by a post. A review is like a post. That post was made by one user.
One user.
Right? What I mean by that, no, I'm not talking about the content of the review, because everybody could make could say the same thing. But if I take a specific review, that specific review was made by one user. You following what I'm suggesting there?
Yes.
All right. Let's use another one again now, right? Let's use in terms of the user and badges acquired. This is badges acquired by the user, right? Okay, and then there's another table here. This table has a list of all the badges. These are all the badges as part of his gamification, right? So this table lists all the badges. These are the user. And the thing is, a user could acquire many badges. Agreed?
Agreed.
And a badge can be acquired by many users as well. Agreed?
Yes, agreed.
So that's a many-to-many relation. But what this diagram is what you call a normalized ER diagram. It removes all the many-to-many and replaces it by one.
One-to-one.
Based on that here, right? Sorry about that, guys. From time to time, I may just have to mute when there's a lot of background distraction, right? Anyway, so this is called badges acquired. So a user could acquire many badges but this badge that is acquired is specific to this user. This acquired badge is specific to this user. And this badge acquired is specific here. So there's one here and one here, but a user could acquire many badges, right? And a badge could be acquired by many. So many goes here and many goes here as well. And one goes on the end. Let's use another one. Let's take a discussion and a user, right? You know what a discussion thread is, right? Like a chat, an entry, right? So in terms of the user and the discussion, right, we're focusing only on this relationship here. A user, could one user, so always start with one, could one user or a user create many discussions, or a user could only create one discussion?
Many discussions.
So many goes here. Now, let's take a specific discussion. That specific discussion, right, was created by many users, or that specific discussion was created by one user?
One user.
One. So one goes here, right? And
Okay.
that's how you do it. So you're not looking at how many arrows coming out from the entity. You're looking at each relationship uniquely, right?
Okay. Yeah.
All right. Cool. Okay. Let's look at another one. This is course and this is review. This is course or subject and this is review. Could you identify? So what I want you to do, I want each of you to identify what goes on the courses side, this side, and what goes on the review side, right? Think of it individually, and I'm coming back to get your answer. When you finish that, also, I want you to look at this one here between, just one second, exercise and exercise question. So the relation between exercise and questions, exercise question, these two, I want you to tell me if it's many to many and which one goes on this side here, which one goes on the other side here. So those two of them between courses and reviews and exercises and exercise questions, right? So look at that. Give me a minute and I'll come back for your answer. Okay, you guys ready?
Yeah.
All right, no problem. So let's start with courses and enroll, right? Is it that's the one we're looking at, courses and enroll?
Reviews.
Or reviews? Sorry, courses and reviews. Okay, Camille, you want to start us off? Which side you want me to go on, review side or courses side?
Oh, I'm thinking a course could have many reviews.
Excellent. So the many goes next to reviews. A course has many reviews, the many goes next to reviews, right? Good. All right,
Yeah.
somebody else now. You want somebody to do the other side for me? Jason? Jay? Oh, okay, anybody else then? Joe, you there? Lennox. Joe, right. So from the review side, a review. So Joe, from the review side, a review, if you take a specific review, would that specific review be from one course or many courses?
One course.
Would be for one course.
Correct, because so when you read a review, that review is for a course, right? So that review that you're reading is specific to a course. So the one will go on this side. Very good. Let's go down to here now with exercise and sorry about that. Exercise and exercise questions. Right. So exercise and exercise question. Just to note, this table here stores the exercises, like the name of the exercise title, the description of the exercise, the level of difficulty, which exercise number it is, like exercise 2, exercise 3 as the case is, how much questions in the exercise, how much gems the exercise is worth for your gamification, or how much stars you're given this exercise, right? Okay, and which unit the exercise linked to, right? Now, that exercise now has questions. So one exercise, and these are the questions in the exercise. So it will have, in terms of the question, each question will have a question number, right? It will have the question itself, and that question is taken from this question table here, right? Okay. So based on this now, this relationship here between exercise and exercise question, can anyone else, so we had 2 who just participated, would anybody else like to assist me in participating in this one? Don't worry about being incorrect as well. So anyone else, come on guys.
Well, exercise can have many questions.
Wonderful. So the many will go next to the question side.
Yeah.
But this question in this table,
This question, just for the question, huh?
right? So go ahead. This question here. Now notice, I want to note, right? This table here, is seeing a table called questions.
Yeah.
This is your bank of questions. This has like 1,000 questions as the case, right?
Right.
But when you actually create a test, when you create a specific test, this is the questions specific to this test.
Right. Right. So the
Question here now.
so a question could be to one exercise.
Right. So this question is specific to this exercise.
Exercise, yeah.
So this is a one on the side here. Good. All right.
A one on the exercise side.
So the
And many
exercise is made up of many questions, and this
Correct.
question here is specific to this exercise.
One to many, right? Okay. Right.
But I want you to know the difference with this question here versus this. This table is a pool of all the questions. Now, the reason why this table was created is because a question from here could be used in many exercises, and an exercise could have many questions. This was a many-to-many relation, and in order to solve a many-to-many relation, you have to break that relation and create an intermediate relation, and that is how this came into being, right? So just to go back a bit, let's look at normalizing an ER diagram. If you had an ER diagram that had many-to-many relations, you have to normalize it. And this tells you the approach to normalizing as well, right? So briefly discuss that the top-down approach to normalization was used to translate your conceptual ER to a logical ER. And what that simply does, it removes any many-to-many relation from ER. So the ER you're seeing here is what we call a normalized or a logical ER diagram, because we remove the many-to-many, right? But you're discussing the process. So after you do your initial ER diagram, it would be what you call a conceptual ER. Then you remove all the many-to-manys, and then you come up with your final version, which is your logical ER diagram. Now, you would indicate if there are any many-to-manys and how you went about removing them, right? So the process of resolving a many-to-many is simply by breaking the relationship and adding a new entity in the middle. So no longer do you have a many-to-many, you instead add a new entity in the middle called the link entity. And the entities before are now linked to this new one instead, okay? So look at an example. The top-down approach to normalization was used as this is where the conceptual ER is converted to a logical ER. This includes removing any many-to-many relation from the conceptual ER. The many-to-many relationship in the e-commerce ER was the relationship between order and a product, whereby an order could consist of many products, and a product could consist of, it could be included in many orders. So we're showing it's a many-to-many. Then we discuss how we broke it up. Now, all you have to do is apply this to one of your many-to-manys, right? This was resolved by creating a link entity called order details, which stores the products that are included in the order. This solved the many-to-many relation by creating two one-to-many relations. An order now has many order details, but each order detail is specific to that order. So now, no longer is the order linked directly to the product. Instead, they link to the order details, which is the link entity. A product could be in many order details, but each order detail is a one product. And then you give your ER diagram. Now, what I want you to do now, right, using how I discussed this here, the relation between product and orders, I created a new entity in the middle called order details, right? And this basically now, so the order is linked to order details and the product is linked to order details. The product and order are no longer linked directly because that was a many-to-many and we have to remove it. Now, what I want you to do, I'm going to do an exercise here with you guys. I want you to find something. Now, this has removed the many-to-many. Now, we just looked at a many-to-many here between exercise and question, right? This was a many-to-many, right? And to resolve this many-to-many, we created this one here, exercise question. So now exercise is linked to exercise question and question is linked to it, but you're not seeing a direct link between exercise and question because that was a many-to-many. So in your write-up, you could use that as a many-to-many that's been broken down into two one-to-manys. Let's look at another one as well, right? In terms of users and badges, a user could hold many badges and a badges could be held by many users. That was a many-to-many. How did I resolve that many-to-many? Any one of you care to mention how I resolved the many-to-many between users and badges?
My badges acquired.
Wonderful. And therefore, what I'm doing, the reason I give you two examples, in order to enrich your write-up, you need to discuss how you resolve a many-to-many. And this is just an example of two you can use, right? So let's use users and badges, right? If we had here, if I were to rewrite here, it would say that the many-to-many relationship in the e-learning or the learning management system ER diagram was the relationship between the users and badges, whereby a user could obtain
Many badges.
and a badge could be granted or gained by many users. So that's a many-to-many. This was resolved by creating a link entity. What was the name of the link entity?
Badges required.
Right. This was resolved by creating a link entity called badges acquired, which stores the badges that are acquired by each user, right? So which stores the badges acquired for the user, right? And this solves the many-to-many, right? So now the new description will be a user can achieve many acquire many badges, right? Or badge acquired could have many badges acquired. So the relation is between users and badge acquired. So a user can have many badge acquired, but a badge acquired is for one user. And then you go now from badge acquired to badges. A badge could be acquired, could have many badge acquired, or could be acquired many times, but each badge acquired is for one badge, right? So that's more or less how you using it. Good. And you could describe generally it's the same thing you're using for your many-to-many. The next thing now is you come up with your ER diagram like this, right? Now this ER diagram, you could look at what you want, what you would like to incorporate. Again, this ER diagram try to cater for as many different functionalities as possible. Now remember, you don't have to restrict your ER diagram based on what you actually built. You have to remember, this is you're describing and creating a very intricate or complex project, right? That is achievable at the same time. So you should try to use as many as you can from here, even though you only implemented a small subset of them. Okay, so in this here, look at a user could have their avatars, right? They could even have backgrounds that they prefer, background color and stuff like that. Now, even in this system, you could even like purchase a course. So you could, you know, like a learning management system, you could even purchase courses as well, right? But you could choose if you want that as part of the system as well, right? You have your discussions, you have your courses, course made up of unit is made up of material. So Travis, earlier on, we were talking about courses, chapters, units. This one uses courses, units, and unit is made up of material, right? So it's the same logic and concept of breaking it down as well, right? Okay, so this is your ER diagram. After you've gotten your ER diagram, the next step now, remember you have to put your one and many, etc., right? Like these here. This is a simpler version of an ER diagram because it just puts, you know, like you have the link, you have one and many with one name for the relationship. All right. Some tools you could use to produce a ER diagram are listed here. So these are different software you could use if you prefer to do your ER diagram. After you've done your ER diagram, your next step now is to create your logical schema. And your logical schema is basically listing all of your tables. So to complete the normalization process, a logical schema of the database was constructed. This includes each table and the attributes for each table as well, right? Such as primary key, foreign keys, etc., right? So what you're going to do now for each of your table, you will list it like this. It's a simplified form. Notice in this form, which is called a logical schema, you're not putting the data type, whether it's integer, real, whether it's mandatory, and all of those. All you're simply doing for each table, you underline the primary key, right? Like here. And if you have foreign keys, it has an asterisk next to it, right? So foreign keys have an asterisk, primary key underline. And under the table, you should know that primary keys are underlined, foreign keys have asterisk, right? And that's your logical schema. You could work backward because most of you have your tables already. So you could just basically, now even this diagram Marcus created, it more or less has all the tables and attributes included. So it was really built to help the students. So now all you do is each table, you simply have the table and the attributes. Of course, you can rename the attributes if you wish as well, right? And that's your logical schema. Now, the last step of the database design is after the logical schema is your data dictionary. And what the data dictionary does, it brings you closer now to actually creating your table using MySQL or whatever you're using for your table. What it does for the data dictionary, for each attribute, it tells you the data type, the length of the field, if it's mandatory like primary key, if it's unique and those other things, and if you want a brief description. And this is an example of a table using a data dictionary. Ideally, you should produce your entire data dictionary, but here you only need to put a sample of one of them or one or two tables here as evidence, but the full data dictionary goes in your appendix, right? So a write-up will include the next step of the design is the creation of the data dictionary. According to Help Language, the data dictionary is a further refinement of the data produced in the logical schema by including the data type of each attribute as well as constraints and a brief description of each attribute. An example of the data dictionary for the users table is included below. See the Appendix 7 for the full data dictionary. Now, so you give them an example as evidence. And of course, you put your best one here, the one with the most amount of details. Because I don't think all of them you may have the time, but not all of them you might actually describe in full detail as this. So if you can, my recommendation is put all the details, and that's the one you're using here in this. And we've completed our database design, right? So that's the end of your database design. Now we have to design the front end of the application. Now, this front end is called the application design. Some people call it the front end design, right? Now, in terms of the front end design, to design the application, this is also simply designing the screens, what the screens would look like. And there are different approaches, and each one is a level of refinement that you can add to it as well. Now, in order to do this, my recommendation is you first understand the principles of good design, which is understanding Nielsen's heuristics, right? So in terms of Nielsen heuristic, which we'll get to shortly, Nielsen has 10 usability heuristic, and you have different websites. My recommendation is to briefly review Nielsen's heuristic, right? Now, just a note, right? There are what you call now this chapter, and what we're going to do is linked to your evaluation chapter. So what we're going to produce next has a very strong link to evaluation. So if you are including the evaluation, it's crucial that you develop this here. So that, and the good thing is, this is so closely linked to the evaluation chapter that a lot of what you put here will be again reproduced in the evaluation chapter. I just want to go through a bit of Nielsen heuristic, right? So what Nielsen did, right? He basically gave principles for designing, for good design. And what people eventually did, some people created like a checklist of things you should include in your design. So for example, Nielsen, one of Nielsen's heuristic is the visibility. That's his first principle, and there are 10 of them, is visibility of system status. According to Nielsen, the system should always keep users informed about what is going on through appropriate feedback within reasonable time. Now, so you state the principle and discuss how you will apply that principle to your artifact, right? So how the software artifact will adhere to this? Well, in order to ensure that the system always keeps users informed of what's going on, every screen or tab will include a title or header that indicates the screen content, right? So every screen will have like a title or header, so you know exactly where you are. You see this slide has a title at the top, you know what it's about, right? The same thing with your application. In every screen you go, it should have a header, so you know exactly where you are in the application. Icons should have a consistent design throughout the application. So the icons you're using, whether it's to save or to cancel, etc., the icons should be consistent throughout. The selected icon or tab will be clearly visible and easily identifiable from other icons. What this means is that if you have multiple tabs, if you click on a particular tab, you should be able to tell which tab you're on. It should be in a different color, highlighted or something like that to distinguish it. Error messages on prompt and menu selections will be consistently located on the menu. So what this is showing is you take Nielsen's principle and you show how you will apply it to your application, right? Now, in terms of Nielsen heuristic, so the screen provides a guide on Nielsen heuristic. They include the heuristic, the description, and how you can apply it to your design, right? So this is visibility of system status. This is examples of visibility. So you see if you're copying a file, it tells you your progress. If you click send on a message, it tells you a message has been sent. If there's an error message, you know, so these are visibility of system status. Now, what we will do, Nielsen has 10 principles. So instead of going through every one like that for you, right? What we did was, and a simpler way to approach it is for each one of Nielsen's principle, there is a checklist, and you can get a checklist easily online. What a checklist does, it gives you a list of different things that they have for each principle. What I simply did was, from that full list, I simply extracted a few of those items that I will apply to my application. So there's a visibility, there's a Nielsen heuristic checklist. For every one of the Nielsen heuristic, it has like about 20 something items to check. But what I simply did was I simply extracted a few. So if notice the numbering system, this is principle 1, visibility of system status. So what I did was I numbered my checklist item 1.1, 1.2, 1.3, 1.4. The one at the start is principle 1, and then the number after it is a sequential number. So for example, does every display begin with a title or header that describe the screen content? Is there a consistent icon design scheme? So these are questions you will ask, and these questions is what you're going to use in your evaluation chapter. The reason is that this is design, and the evaluation chapter is linked to the design. The evaluation is an evaluation of the design. So what you will see, for every one of the principle, the 10 principle, I have basically given you a checklist. So every one of Nielsen, you'll see a checklist. So the principle 3, principle 4, there's a checklist. Principle 5, there's a checklist. Principle 6, principle 7, 8, 9, etc. Why do we need these? So this is the design chapter. I want to just exit this here, and I want to go to another. Chapter, right, which is the evaluation chapter, and I want to show you why it is linked. And that's why if you do a good job here, it simplifies it later on, right? So let's take a look at the design chapter as well. So if I go to lecture notes, right, So if I go to, evaluation chapter, you will see those same set of tables being done because you're using these principles to evaluate the application. So this is my evaluation chapter. If I'm putting it here and I'm scrolling through it, and when we're doing the evaluation, you will be simply giving a score of either not implemented, partially implemented, or fully implemented to these principles. So if you look at it, you're seeing these same principles here, and you have a score next to each one. So for every one of the principle, you're simply putting a score, like fully or partially implemented. So if you develop this here, you're going to, your whole evaluation chapter is basically the sum of these. So if you do this well, your evaluation chapter wouldn't have a lot more for you to do. All right, so I'm closing off the evaluation chapter, but basically what I've tried to do is to show you that when you set up these criteria in this chapter, which is your design, when you go to your evaluation chapter, which is over here, all you need to indicate now is if you have fully implemented it or partially implemented it throughout the application. So that is why this is crucial here, okay? All right, let me just close off this here. Let's go back to this here now, guys. So each one of Nielsen's principle, max out this here. So for each one of the principle, you're simply stating the principle here or the checklist. So basically you're saying are prompts constructively stated without overt or implied criticism? Do prompts imply that the user is in control? Now the heading Nielsen heuristic here is helps user recognize, diagnose, and recover from errors. What Nielsen is saying, when you build an application, that application should help users recognize an error. And how will they recognize an error? Through helpful messages, diagnose, and even recover from the errors. How could you do that in your application? Well, to incorporate that principle, what you're saying is ways you can incorporate it is prompts stated constructively without overt or implied criticism. Do prompts imply that the user is in control? Are prompts brief and unambiguous? Are error messages worded so that the system, not the user, takes the blame, right? Are error messages grammatically correct? Does error messages avoid use of exclamation points? Do error message avoid use of violent or hostile words? If an error is detected in the data entry field, does the system place the cursor in that field to highlight it? All of these are ways. So it's more like a question because it's asking you if you've done this, right? Because these are, if you've done it, then these are ways you could implement, you could satisfy Nielsen heuristic. So again, there are 10 heuristic, and for each one of the heuristic, I've given you like a checklist you could use. You could use a subset of these, or you could use the full checklist and choose your own items from that checklist. Good? Now that you've done this, what this simply does, it helps you now to understand the principles of good design. And now that you understand the principle of good design with layout and all of those now you could start sketching your screens. Now, in order to do your sketches, these sketches, you could simply use paper and pen or pencil and sketch them, take a picture of it and insert it into your project. So these are hand sketches. It's a very low level sketching, right? It doesn't require a lot of intuition. It's simply to help you to figure out the layout of the form sort of thing, right? So the recommended approach to it is this, what they indicated. I know for many of you, you'll be rushing the process, so you just draw a sketch just to have a sketch. But the rule of thumb is that, you know, they suggest the best thing to do is do about 6 different sketches of the same screen. And when you do your 6 different sketch, determine which one is the best one. And then that will be used to develop your higher fidelity prototype, the wireframe, the roof, and other stuff that we'll be doing, right? So the sketch, what they recommend is do a few sketches of the same screen and then come up with the one that is best. And then from there, that is the one that you will develop now when you go to the next stage, which is wireframe and low fidelity prototype. It's much the same way as well. Like, for example, if you're going to build a house, you don't just watch one house and say, I'm building it just like this. You may have looked at hundreds of houses to come up with the element, and that you may not even find one that matches exactly what you want. So you may have to take elements of different ones to put them together. That's why it's suggesting don't just do one sketch and say, well, that's it, right? Try to come up with a good sketch. So this is an example of the write-up for it. Sketching using pencil and paper is a fast, low-tech way to explore ideas. Sketching doesn't require a lot of details and is a wonderful way to explore different solutions to design problems. He quotes someone. Naylor recommends doing 6 templates of a given screen as he believes it forces the designer to look at 6 different ways to interact with the system, as well as each design is a progressive graduation of design idea. So what he's saying, your first one should not be your best. Everyone should be a progression and improvement, ideally, right? Once there's a high level of satisfaction with a sketch, then the screen will be used to develop a higher fidelity, for example, a wireframe or a low fidelity prototype. Right? So this is an example of a sketch, right? It's hand-drawn, etc. It is not of a high quality, etc. But the whole idea is to help you to recognize now, you know, like just general layout and stuff like that. It's very low. If it's wrong, it's easy to redo it because you're just doing it on paper quickly. Good? You could even draw it on a whiteboard and take a picture, right? If you want, so you could use markers on whiteboard, do a picture, then erase it, etc. Do another one, right? Your choice. After you've done your sketches now, right, the next step now is a continuous refinement. So from those sketches now, you move to a wireframe. And the purpose of the wireframe now is really to make it, your design a little better as a higher level as well, right? So wireframes really still allow the design more detail around the space allocation, the content prioritization, intended behaviors as well. While they can look somewhat sparse without styling and color and graphics, it is deliberate because styling color graphics can be distracting at the early stages. So they prefer to leave that for the next stage, which is your low fidelity prototype, right? So in that case here now, you have your wireframes, right? And these are examples of wireframes. Colors and stuff like that are not used, but notice what it is trying to do. It's showing you better now. Before you had a set of abstract stuff. Now you can actually see layout a lot better planned and organized than the previous version, right? You can actually see proper detail of breadcrumb being here. So before you might have just said breadcrumb, here you've seen an example. You're seeing, you know, you could tell which ones are hyperlinks, etc., right? You could see the information here. It's not putting actual data, but you're seeing like artist 1, artist 2, or track 1, track 2, etc. Your search feature over here. So it gives you a proper layout or adding to a cart, those sort of things. So this is an example of a wireframe, right? Okay. And this is another example of wireframe, and wireframes are showing you how the pages are linked. So if you click the sign in from here, it goes to here, right? And or if you click register, it goes here it goes to the registration page, and after you register, it takes you to here, which is the home page, right? So these are different ways to represent your wireframe. And the next step now, after you've done your wireframe, so this is another wireframe. Notice you could even narrate your wireframe to explain your design decisions. So like home, clicking on home navigation link causes you to reload the home page. Clicking on dashboard will go to the dashboard page, right? They say click to unlock lesson name and go to the lesson page, which will dynamically display the lesson content. This here is your course progress. It tells you about your progress. This one is specific to learning management system, right? Your current lesson is, it tells you where your current lesson is and any quiz feed as well, right? Etc. Right? And you have a picture slide showing this area here, etc. And it welcomes you as well. Notice it tells you where you are. This is SQL Interact, so it tells you the name where you are. This is the programs SQL Interact this person create, etc. Right? So this is an example of a wireframe. And then the last now, as you get better and better, now you can add colors and stuff like that. And that is where the interactive prototype comes. You can add colors, logos, etc. The interactive prototype looks like the actual thing, right? So the interactive prototype looks like an actual example. So take a look at these. These look like actual application, but they're not. They're simply what you call interactive prototype, which is still design, right? So if you did user experience design, this is what you are required to produce. At the end, this is on a mobile device, what your application should look like, right? So notice this is all design. It is not functional, but it shows you what your screen with colors, layout, proper font, etc. Now that you have this, you can imagine how much easier it is for you to design your screen. You know the color you're going to use, you know the layout, you know the actual words, etc. So you don't have to figure it out by in the implementation. The implementation only focuses on programming it now, because all the ideas, the layout, everything was covered previously. And this is what you call interactive prototype. To build your interactive prototype, you could use Axio, and I've given you like a license key for Axio. CTS College had signed up for a license for Axio, and this is the license key here. We've had it for a few years. I believe it's still working, so, right? Or you could use other tools such as Balsamic and whatever, but it's a bit more expensive, right? But you have a free version of Axio you could use, right? Okay, and this helps you to build an interactive prototype. And it's called interactive because you could actually, with your interactive prototype, you could click and you could see how it navigates from one screen to the other, etc. So you could actually see how they all link together, right? And that's what you call an interactive prototype. And this is an example. And once you have this now, that's the end of your design phase. You've completed your design. And now it's just simply now to go and start coding. Good? Any questions so far now as we come to the end of this particular chapter?
Does actually have a learning curve, or it's fairly simple?
Well, I've never used it, but I believe with any software, there may be a small learning curve, but
Well, YouTube or stuff, right?
It's fairly simple.
Very simple.
Yeah.
Okay, cool.
Ravi, the checklist, you could just search online for it. The heuristic checklist.
But you know what? I have it. I've downloaded it, and what I'll do, I'll try to find it and send it to you all as well, right?
Okay.
I have a question unrelated to this chapter here.
So
I want to reference the first 3 chapters if you have a recording thing. I missed those classes.
Yes, I would have sent out now only the chapter 1. I believe we didn't have a recording for because I had to pause the class in order to go and call students, and I forgot to put back on the recording. So all the other chapters were recorded. I would have sent emails to all of them, but what I've done, if you go to the CTS YouTube channel, right? If you go to YouTube and you go to the CTS channel, if you search my name, I've tagged my name, I'll tag Gani's name as well, right? So you should find the chapters there, right?
All right, cool, thanks.
What I could do as well, I could also try to, if you're not getting it, Len, just let me know and I will go on YouTube, find them and send the links for you, right?
All right, cool, thanks.
No problem, bud. And that goes for everyone as well, guys. I put them on YouTube because the whole idea is to make it more accessible to you, so you don't have to go and do searching too far. Once you could get the CTS page, all right, you could just search for Ravi Raghunath, or you could search for IT project or some of those terms, and you should find it, right? Any other questions or anything like that for you guys?
Nope.
All right. Well,
the software for drawing the ERD diagrams.
Right. So I've given a list of software you could use for, but of course you're not limited to these, right? So in the lecture notes as well, just after the ER diagram, I think I've mentioned the software you could use for it as well. Just a second. ER diagrams.
I want to use that.
Right. These are a list of them, right? Software tools to produce ER diagram. You could use Lucidchart, ER diagram, Smart Draw, Visio, right?
Already, I wake up so late this morning.
Okay. Thank you very much. So I said, I think I have to go back to that. I didn't see it.
Well, guys, that's it for me. You have a wonderful night, and I'll be sending out now the video will takes a little while to convert, and once it converts, then I have to upload it. So by tomorrow I'll provide the link for the video, right?
Thank you.
No problem. Thank you very much.
And have a good night. Stay safe, everyone.
Yeah.
You too.
Yeah.
Night.
Bye.
Bye. Good night.
Good night.
Is that good night?
Yes, that's a good